Hello everyone and welcome to the channel. I'm Emmanuel, I'm a former Boeing 737 pilot and member of the PMDG 737 tech team. In today's video, let's go over a walkaround of the Boeing 737-700, and obviously this would be the same for the other variants, 600, 800 and 900 as well. We're going to do this, number one, as a tutorial for how to conduct a proper walkaround on the Boeing 737, and of course, number two, also as a way of exploring the brand new model that comes with the PMDG 737 update. So let's go outside and get a walkaround started. Walkaround on the Boeing 737 basically starts where the pilot's coming out. So you're coming out here, and then you're starting right next to those doors. So what exactly do we see over here? That's the TAT probe, so the temperature sensor that's fitted to the aircraft. Now, on the front we have the AOA vane, which measures the angle of attack, and then we also have the pitot tube, which is measuring the airspeed for the captain's speed indicator. Now from here we are going to go ahead and have a quick look down into the wheel well, where we just check for the general condition and make sure that there are no damages, bird strikes or anything the likes. Now in here, a couple of things to pay attention to when you are walking here. Number one is that you don't have any remains of birds or something, and number two is that there are some control cables going along over here. You can see them here and here, and those should really be in a good shape. Those are basically what's controlling the actuators down here, which are effectively controlling the angle of the nose wheel, and you really don't want those cables to rupture. So that's what you got down here. Apart from that, you'll also have a look at the nose gear doors, make sure that they are attached tightly to the aircraft, and that's that. Now we also do check for the forward E&E bay door to make sure that that thing is latched. Now from there, it's a good idea just to take a little bit of distance from the aircraft and just have a look at it from this angle, because at this angle you could really see if something's been bent on a previous flight. If someone did a very hard landing on one side only, or on one landing gear only, then over here you could probably get the best impression of any possible asymmetry that you may find in the aircraft's fuselage. Now from here we are going right back to the other side, and we are checking the first officer's pitot tube. Again, that's what measures your speed. You check the standby pitot tube and the AOA vane on this side, basically the same as on the other side. Next up, down here we do have the external power access door. You can open and close this, but if you do that, then you need to remove the ground power unit first. Now, a couple of buttons in here in case you do need them, which you can also control, which are the nose wheel well light that turns on the light down here in the wheel well. Then you do have the pilot call button, which sounds a chime in the flight deck, and then you do have the external power lights, the connection light indicating to the ground crew whether the power is connected, and the not in use light illuminates when the power is connected but not supplying the electrical system. So only if that light is illuminated, the ground crew could actually detach the external power unit from the aircraft. Now that would be the case, for example, when the crew has already shot the airplane down cold and dark and left for home, or when the APU has already been put on bus and therefore the external power unit is no longer supplying the aircraft. All of that is of course simulated on the exterior panel as well here. Then we're going a little bit further back and we're checking the first door. What you always want to look for with the doors is that those handles here are flush with the door, so that they're really inside their fitting and that they are not creating additional drag. Next up over here we do have the emergency exit lights, not to be confused with the wing lights that you have in the back over here. Emergency exit lights, you have one next to each door, so that if you do use the escape slide to get down, then you are going to have some light on the evacuation area shed by this. Going further back then, we got the static port. Those are what measures the pressure for the altimeter and also used for your speed indicator. And you basically want to make sure that those are not covered, for example, by some stickers that may be put on there if the aircraft is getting washed, so that no water gets into the system. We also have an auxiliary one down here for the standby system. Now, moving a little bit further back, we do have the cargo compartment. Basically just want to have a look in here, make sure that there's not been any fluids spillage or anything the likes that doesn't belong in there. Now, from there we are going further back, and we do have the wing light over here. Then we got our ram air inlet door over here, and here we basically want to make sure that there are no birds nesting in there. Birds do like these areas, especially because they tend to be warm, especially in autumn or spring, so make sure that there's nothing in there, and don't lose your flashlight when you are shining in there. Believe me, it happened, and you don't want to make that call to maintenance to come and crawl in there, open up some panels to get your flashlight back. So landing lights, two different versions modeled, LED and conventional, and if those are missing when you're conducting a walk around, just press Shift-C to go to the cockpit view for once, then the plane can load all its custom gauges. MSFS prevents it from doing that when you spawn in for the first time and you're in the outside view, and since there are two different types of lights available, which are physically modeled, the plane just needs to load its gauges first. From there we're getting to the engine. CFM56 engine, lovely details on the cowlings over there. Over here we do have the starter, or the external starter unit that you can connect. In the back we do have the thrust reverser lockout pins, which could be fitted over here, which you want to make sure that they're not in. And then going up to the front, we have a good look inside the engine. We check for the condition of the acoustic lining down here to be in a good shape, and that one basically just absorbs a little bit of the sound that you would find around the aircraft. Now, we are checking our pressure sensor to be in good shape, and then we have a look at our fan blades, especially the leading edges of the fan blades, but also try to have a little look behind them, just to see if there may be any feathers in the compressor section, in case a bird was lucky to make it through the first line of blades. Now, with that done, we are moving around the engine. Quick look beneath the engine. With only 8 degrees angle of bank on the landing, your engine pod may hit the runway, and you just want to have a little look beneath there to make sure that there are no scrap marks down there. Engine oil access doors are closed, and then we can already move along the leading edge of the plane. Now you do have these ports over here. Those are outlets for the hot air that the wing anti-ice is getting supplied with, and basically those can get a couple hundred degrees hot, so just make sure that none of these are blocked. Over here is the refueling panel, which we can also open. Now, 737 by far not as sophisticated as Airbuses are. Basically what you got is you have the valves over here for the wing, for the right wing, for the left wing, and for the center tank. When you want to refuel the aircraft, open those valves, and then the respective tank is going to get refueled. The valves have a huge lag in them, so always stop like 50 kilos before the target figure, and then just open them in short, sharp bursts in order to refuel the aircraft. I can tell you it's a very poor system, and fueling the 737 precisely is pretty much impossible. You'll always have inaccuracies of up to, 100 kilos, 150 kilos, just because it's so difficult. Over here's where you'll do plug it in then. Alright, now that much about the refueling panel, then let's continue on along the side of the wing. And the next thing we're looking for are the lights. You want the green lights on the right hand side of the plane, red lights on the left hand side of the plane. Then you also have your strobes up there. Again, different type of lights, whether you have the LEDs or conventional lights. Now, if you do have LEDs and if one of them is not working, any one of those units may be broken. So there's one unit, second unit, all of both, which have two bulbs. One unit may be broken, the other one needs to be operative, then the airplane can be dispatched according to the MEL. And if that is the case, just make a hard landing on the next time. If you do have the LED package, 99% chance it will work again after it gets a proper bump. Alright, moving along, we do have two static quick dischargers on the wing. And then we can make our way to the back. We do have the ventilation inlet and the pressure relief valve over there, and we basically want to ensure that this is not blocked. Moving along the trailing edge, we got our ailerons and our flaps and the flap fairings. We basically want to make sure that those are in a good shape. No birds sticking in there, no sign of any damages. Did you know the entire trailing edge of the flap fairing may be missing, and the plane is still dispatchable? Uses about 2% extra fuel. Alright, getting to the landing gear then. PMDG does model damage to the landing gear and the brakes wearing down. Now, check for the condition of the tires and then also have a look up here at the brake wear indicator pins. Basically, when the brakes are wearing down, you will see that thing here become smaller until it is eventually flush with the metal. Once you got about 1 millimeter left, you have around 7 days of flying on the plane, so maintenance will be on top of it, but you may want to report it to the airline anyway. Alright, then we're heading into the wheel well, and the first thing we will see is down here. We got that little pin, and this is a shear pin. So basically, since there is a lot of vital equipment inside the wheel well over here, we'll get to what is what in a few moments. But basically, when you have damage to the tires and, you know, there is rubber pieces flying around when the tire is rotating and that kind of stuff, and then you're retracting the landing gear, then Boeing thought that, okay, if those pieces are shearing that pin off, then the landing gear retraction's immediately going to stop, the gears are going to fall back out. And thereby they prevent damage to any of all those vital components that you have in the wheel well down here. Now, let's have a quick look through the wheel well. What is what? We do have the hydraulic reservoirs for System A and System B, and we also have the quantity indicators up here, and you do want to check those. Those are animated in the PMDG, and you want to make sure that you do have sufficient hydraulic quantity in both main systems. Then you also have the standby hydraulic system, and it's a pot over here. You don't have a quantity indicator for that though. On this side we have the nitrogen generation system, which only has 3 lights, telling you whether it's operational, whether it's downgraded or inoperative. Now, the airplane is dispatchable in any of those states, and what this does is to generate nitrogen, which is filled into the fuel tanks, rather than fresh air, so that fuel tanks cannot ignite if any fumes would build in there. You also have your APU fire controls, so if nobody's inside the aircraft, which isn't supposed to be, but if nobody is inside the aircraft, the APU catches fire over here, you can extinguish it. Now, from this side, we can later on move on to the other side, which we will do, but let's first of all get to the back of the aircraft and see what we can find over there. Now, emergency exit light down here, which is there because of the overwing exit. Remember, passengers are sliding down the trailing edge of the flaps, and then this light is going to illuminate the area where they reach the ground. Now we got the aft cargo compartment where we gotta have a little look in. For example, you don't want to find that segway, which is banned in most airlines because those things do like to catch some fire. I just love this. And you want to check for the general condition of the hold, you know, make sure that there has not been any leakage of dangerous goods or something inside your plane. Next, we are moving further to the aft, and we got the outflow valve over here. Now, the outflow valve, as the name suggests, is the valve at which air is flowing out from the cabin. So the packs are pumping a constant volume of air into the passenger cabin, and depending on how far this valve is opened, you will have proper control of the cabin pressure because, you know, valve is open further, more air flows out, therefore cabin pressure reduces. Valve is shut close, but the packs are still pumping air in, which they're always doing, and then the cabin pressurizes. Quite as easy as that. Now there's a safety relief valve that helps in case of an overpressure condition. So for example, if the valve would jam shut, then instead of the cabin just popping like a balloon, you will trigger that safety relief valve and then air is going to get out. Now, same thing located down here in a second version. Alright, then we are moving a little bit further aft. You got the APU air inlet over here, currently closed. And generally, when you see this type of shape on the fuselage of an aircraft, there's always an air inlet. It's just the most efficient shape. Now, up here we do have another pitot probe, and this one is for measuring your speed for the elevator field computer, which is the one that controls the force feedback on your control column. That's what this one does up here. Now, stabilizer, you just ensure that there is no type of damages over here. You ensure that it's in the proper position for the trim indicated in the flight deck. And then we're looking for 3 static wick discharges on the stabilizers. 1, 2, and 3. Now, on the top of the plane, we're looking for 4, 1, 2, 3, and the fourth one is at the top. And any one of those may be missing on each one of those surfaces, and the plane is still dispatchable. If more is missing, then you will need maintenance. Right, APU air outlet and the strobe light in the back over there. Contrary to Airbus, you don't have position light located over here on the 737NG. You only have the strobes. Different on the Max, but yeah, different certification requirements from a different time. On the side of the aircraft, you are checking for the same thing, and then we're going back to this thing over here, or rather these 5 things. Now, these are simple holes in the airplane fuselage. That's because the pressure bulkhead for the cabin is located over here, and while the cabin pressurizes, the tailplane where the APU is located is not pressurized. Now, if this thing didn't have any holes, connections to the outside world, it would mean that there would be a huge pressure acting on this in cruise flight if you had ground air pressure on there all the time. That's why you got these little holes down here, which have to be clear. None of these can be obstructed, otherwise the plane is not dispatchable. Now, moving further front, down here you got the shithole, aka the laboratory service panel, where they empty the laboratory tanks. There's also a water tank located back there. Alright, apart from that, on this side of the plane, we basically have the same things that we have on the other side, but there is one more thing that I want to have a look at inside the wheel well. And that is up here, the fire extinguisher bottles. Now, you can see you got 2 squibs. The APU has a separated one, and either of those 2 can be fired into both engines. What you want to make sure, because you don't have any indication for it in the flight deck, is that you do have sufficient pressure on the indicators down here. Otherwise, the bottle may be empty, and yeah, you don't want to fire an empty bottle into a burning engine, do you? Alright, and that's what you find in the 737's wheel well. Lovely amount of detail that PMDG have put into this. And with that, we have basically already completed our walk-around. So, I do hope that you like this one. Apart from this side of the plane is really pretty much the same as the other side. You do have the air stack control panel located down here, which you can actually operate. Standby power system, normal power system, and then the extend and retract buttons over here. This is your air stair door, where the air stairs are actually going to come out of. Well, and that's pretty much everything there is to this. So, I do hope that you do like the new PMDG model. I do hope that you now know how to conduct a proper walk around with it, so that you can actually make good use of that model. Thank you very much for watching. As always, be sure to like, comment, and subscribe, and if you really love what I'm doing on this channel, I would appreciate a small donation through the Buy Me Coffee link in the video description below. Thank you very much, and I'm really looking forward to seeing you all again on the next one.